Without using your calculator, I want you to sketch the line that is the graph of each linear equation written in general form. So these are all written in general form. A great way to graph it is which form. Which of the following, or which of the forms above are forms that we would like to use in order to graph. As I said above, the best form for graphing is your y equals mx plus b, your slope-intercept or gradient-intercept form. I'm going to go ahead and first put these all into gradient-intercept form. This one I just need to add 4 to both sides. You're subtracting 4. In order to undo subtraction, you need to add y equals 4. I also kind of want to get this x alone, even though technically mx plus b form, you would put these still together. If I get x alone, I subtract 3 from both sides, getting rid of this plus 3 to move it over. I would subtract 3, so you get x equals -3. This is going to be a horizontal line. This is going to be a vertical line, so that's kind of cool that we get to see that. This guy, I want to go ahead and isolate for y. So if this is something that you're struggling with, as always, I think you should be practicing this because it's really important. In order to undo all of this, we've got some multiplication going on with this 5 and a 3, and we also have a subtraction. Realize that we always talk about PEMDAS. When we're trying to undo, we do the opposite of PEMDAS, right? PEMDAS is this way. If we're trying to undo and isolate a variable, we do the opposite of PEMDAS. We call it SADMAP, which means that we need to do subtraction and addition first. If there's any sort of subtraction addition situation going on here, we need to undo that first, which means we need to add 6 to both sides. Once you've added 6 to both sides, we still want to isolate for y, which means we need to get rid of this whole chunk right here. Getting rid of whole chunks are still addition subtraction, because I'm not trying to separate 5 and x, right? I don't want to separate those out. I don't want to break the multiplication that's between them. I just want to move that chunk over. So I'll subtract it. 3y equals 6 minus 5x. Then I want to get rid of this 3 so I can get y by itself. I'm dividing 3 from every single term. So that's going to be y equals 6 divided by 3 becomes 2. I'm going to leave that -5/2 as still 5/2 because it's a slope, right? And so it's easier for us to understand slopes when they're left in fraction form. Okay, so now we've isolated for all of our y values. We've turned everything into slope-intercept form. And now our goal is to graph these guys on the same plane. I'm going to go ahead and make my x and y axes very much in the center. I'm first going to go ahead and graph A. While comparing this to y equals mx plus b, realize that your y-intercept is this b value right here, and it's the value that is not being multiplied to x. And so sometimes it can get confusing because the order doesn't stay the same. Here it's 2 minus 5/2x, but we can rewrite that. Realize that this is -5/2, so that sign needs to stay with that number. You can always flip it around, and that's the exact same thing. The term, the number that's not being multiplied to x is 2. That is going to be our y-intercept. Our y-intercept is 0, 2. So if I'm trying to graph that guy, I'm going to go ahead and put a point at 0, 2. And then I need to go ahead and start counting my slope and find a second point. All lines require 2 points in order to be defined. So if my slope is -5/2, that means that I go down 5 and right 2. So I can count here down 1, 2, 3, 4, 5, right 1, 2.